Hello again to my wonderful Chemistry 20 students. We're on to our third concept of the week, which is the combined gas law. So essentially we're taking those different principles and properties of the gases and seeing what happens and we put them all together. Have a look at the pictures that are on the page there, and the variables we've looked at so far that definitely have an impact on gases are, of course, our temperature. And the next one, you may or may not know what that is. That's a barometer, and the purpose of a barometer is to measure pressure. And our last one there is showing 3D structure, which anytime you got 3D container that can fit something in it, there's our volume. So keep all three of those in mind as we're focused here. I also want you to keep in mind what measurements in terms of what sort of units we have to use for all three of those. All right, let's keep going. Now, like I mentioned to you already, pressure, volume, temperature are our key things that we're dealing with here. And all of those together have this new formula called the combined gas law. Combined gas law, lucky you, is on your formula sheet. So you will absolutely be able to access it anytime you need to. It involves all three of our variables at the exact same time. Do not lose track of, please, 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 super important, just like we worked on in the previous lesson, that every temperature you use when it comes to gases are always, always, always going to be in that Kelvin scale. Okay, so we'll review a little bit on how to convert something in degrees Celsius into Kelvin. Please also take note that from a pressure perspective, we're going to focus for this year anyway, that all pressure measurements are going to be in kilopascals. Okay. So same measurement that we used before, but just to clarify. All right, here we go. There is that wonderful world of your brand new formula. Dun, da, da, da. Okay, and the logic of this is very similar to what you were seeing before, where the ones are, that equals initial. Whoa, what am I doing here? No, no, no. Get out of that. There we go. Okay, so 1 equals initial, and anywhere that you see a 2 equals final. Okay, so in terms of what the other variables are, they're exactly what you'd expect, right? Based on what we saw before. P is pressure, initial and final. V is your volume, initial and final. And T is your temperature, initial and, of course, final. When you're going through it, I mentioned on the previous page, pressure is in kilopascals. Temperature, of course, has to be in the Kelvin scale. That's the key. Volume, guys, for volume, you just have to make sure that the units are consistent, okay? So units are, what's my pen doing here? The same. So in other words, if I start in milliliters, I better finish in milliliters. Or if I start in liters, I better finish in liters. If I start in macroliters, I better finish in macroliters. Don't lose sight too that these are definitely always in closed system. Closed system just means that matter is not allowed to go in and out. Only energy can. Whereas an open system, it would be really easy for things to go in or something that was already in there to come out again, right? That's that difference. All right. Here is the wonderful world of one of our very first examples. So very similar, guys. You need to write down all your knowns. But let's check what's what here first. Notice we've got 15-liter weather balloon. Well, as soon as you see liters, that means you've been given a volume. This is really important too, under STP conditions. That came up the other day, standard temperature and pressure. So you've now been given a temperature value and a pressure value that you'll have to find on your data booklet. Keep going after 10 minutes. Okay, cool, 10 minutes, but really not a big deal. All that shows is that there was something that it started with and then it finished with something else. It doesn't actually factor into your calculations at all. As we continue on, we get some more information about the temperature. So the balloon after 10 minutes has a temperature of negative 38 degrees Celsius. Little alarm bells should be going off in your head. That's degrees Celsius. We can't use that. We need Kelvin. You're also given a final pressure of 80.5 kilopascals. The whole goal of the question is to calculate the new volume. Now, notice how I use the highlighter there. That's done really intentionally. If you look through it, we have a number 1 volume, and we're looking for a number 2 volume. We have another 1 temperature that we start with, and a number 2 that we finish with. We have a number 1 pressure that we start with, and a number 2 pressure that we finish with. That leads beautifully into our combined gas law. I usually start these and I'll write down all of my variables so I got them. So I've got an initial volume, an initial temperature, an initial pressure, a final volume, a final temperature, and a final pressure. And then start filling in what you've got. Initial volume, of course, is that 15 liters. Initial temperature, okay, go to your data sheet and have a look at it at STP. Don't even bother writing the degrees Celsius. Go right away to those Kelvin, 273.15 Kelvin. Same thing, look at the pressure at STP. It's 101.325 kilopascals. You must write units. This needs to be an absolute normal habit. Okay, keep going. At V2, the final volume, that's the whole point of the question. That's what you're looking for. Your T2, here's where things get interesting. Negative 38 degrees Celsius. Not good enough. So you need to add your 273.15 to get the actual temperature that's final. Add those two together. Don't forget about the negative on the 38. We get 235.15 Kelvin. Remember, guys, you can pause this at any point so that you can try to figure out as you go. Our final pressure is given to you in the question, 80.5 kilopascals. Now, guys, I really go through this step by step in the notes that I've posted. I recommend that you look at them as well to make sure if you're not quite following that you can see that here's what's next, etc., etc. Okay, next step, speaking of which, is write down your formula. We've got P1 V1 over T1 is going to be equal to P2 V2 over T2. Okay, plug in what you know soon, but first, isolate the variable. Okay, consider this. We are looking for that final volume, which means we need to isolate this V2. That's done algebraically. I warned you guys that the algebra here gets a little more complicated. The P2 is really close to the V2, so get rid of the T2 first. It's being divided by T2. The way to get rid of that is to multiply by it. What you do to one side of an equation, you always have to do to the other. These ones will cancel out. Okay, let's just go through this really step by step so you can see what I'm doing. Now we have T2, P1, V1 all over our T1. And on the right side of the equation, that second pressure is still beside the volume, which is our absolute goal to isolate. We need this by itself still. Okay, so what's in the way? Well, the second pressure. It's being multiplied by it. How do you get rid of something being multiplied? You divide. So divide by P2. What you do to one side of the equation, you do the other. Those cancel out. Life is lovely because we have finally gotten to the point where our V2 is completely isolated and we can actually solve for it, which is perfect. Okay, there we go. Next step, take that equation that just got figured out and plug in what you know. When you plug in, though, I will remind you, you must include units. This is important, okay? So start from the beginning. Our T2 is 235.15 Kelvin. This temperature is being measured by the initial pressure. Really watch your ones and your twos here, guys. 101.325 kilopascals, and I'm going to run out of room on the top there. So this is technically on the top 2 times my 15 liters. All of that multiplied together is divided by the first temperature, which is 273.15 Kelvin, and our final pressure, 80.5 kilopascals. Now, I don't always go through the step-by-step here and show what the top totals and the bottom, but I want to emphasize that you need the total amount of the top before you actually divide by the total amount on the bottom. Be careful on your calculators. Be smarter than your calculator. Another way you can do this if you want is put brackets around everything on the top before you divide by brackets around everything on the bottom. I cannot emphasize this enough. You're going to get wrong answers if you don't do that. Okay, there's my top divided by my bottom. Check out what's going to happen in units. I've got kelvins on the top, kelvins on the bottom, kilopascals on the top, kilopascals on the bottom. I'm going to end up with liters, which, good. That's what I'm looking for, my final volume. We end up with 16.25338. It keeps on going liters. Go back to the beginning. When we are right at the beginning of this actual assignment, there are 2 sig digs here. 10 doesn't matter, we don't use it. 2 sig digs with the temperature, 3 with the pressure. While honestly, 3 isn't a matter because we're already down to 2 between the 15 and the negative 38. So from an answer perspective, I need to have V2 is equal to 16 liters. And that, folks, is my correct answer with 2 sig digs. 2 significant digits. There's our first question. Remember, you can pause, go back and look again, but I'm going to do another example with you. Okay, check out this one. Same thing. We're going to read it to look for all the different stuff. So a 3.5 liter piston, as soon as you see liters, we've got a volume. Then it says it holds a gas at a temperature of 30 degrees Celsius. Remember those warning bells, has to be in Kelvin. The piston is compressed, that means pushed down, until the internal volume is 850 mils. We've got another volume. With a temperature of 68.5 degrees Celsius, another temperature in the wrong units though, and here's our first pressure. Look at this, you already can kind of see how the question is going to go. I've got a first and a second volume. I've got a first and a second temperature, and I've got a first, oops, nope, not a first, read carefully, a second pressure. I need to know the whole point of this question is what the original pressure is. In other words, I need P1. All right, same dealio. Start with your variables. And in terms of which one you write down first, doesn't matter. I have to do the volume first, but however you do it. So V1, T1, P1, V2, finals here, right? T2 and P2. Our initial volume, no big deal, 3.45 liters. Our initial temperature, this now becomes starting to be a big deal. 30.0 degrees Celsius, not good enough. Add your 273.15, and you're now going to get a temperature of 303.15 Kelvin. That's the number you need to actually use. Don't lose track of that. Your first pressure, that's the whole point of the question, guys. We don't know. V2, another spot where you really need to stop and think. 850 milliliters. Consider what's happening here. I have a first unit for V1 in liters. I have the second unit in V2 in milliliters. That's not okay. These things have to match. So we got to divide it by 1,000. We're going to actually have here 0.850 liters. Now my units match. Now I'm good to go. Temperature, final temperature is 68.5 degrees Celsius. Again, add your 273.15 so that we can convert this to Kelvin. Gas laws, always in Kelvin, no exception. 341.65 Kelvin. We're getting close here. P2, the pressure is 135 kilopascals. And once again, our whole purpose of this problem is to look for this, our initial pressure. You should know what's coming next. We need to write down our formula. Okay, so here we go. P1 V1 over T1 equals P2 V2 over T2. This time, our goal is to isolate P1. We need this by itself. So we still go through a similar step-by-step in order to do so. All right. So why is it disappearing? Come on, silly thing. There we go. Okay. If P1 needs to get by itself, the temperature on the bottom is in the way. How do you get rid of a divide by? You times by it. We do to one side, you do to the other. These cancel out. Move on. Now we're left with P1 V1 is equal to P2 V2 T1 all over T2. Going from here, we're still trying to get, don't lose track, P1 all by itself. In the way from that is our volume. So divide by V1, what you do to one side, you do the other, but those, of course, are going to cancel out. We're left with exactly what we want, which is our P1. Final formula, P1 equals P2 times V2 times T1, all of that divided by T2 times V1. Be careful with your multiplying. Let's plug in some stuff, include your units, that way you can see what starts to cancel out. P2 is 135 kilopascals. And our second volume, don't forget to use what you changed, 0.850 liters, that's important. And we're going to have our final our initial temperature here is 303.15 Kelvin. That entire top thing, all of that has to be divided by the second temperature, which is 341.65 Kelvin, times our volume that we started with, V1, 3.45 liters. Like I said, don't lose sight of checking out the units there. Kilopascals on top, it's only there, so it doesn't cancel out. But liters on top, liters on bottom, gone. Kelvin on top, Kelvin on the bottom, gone. Our final unit, which is exactly what we want, is kilopascals. Please remember, you need to divide all of the top by the entire bottom. Be careful with how you do this. When everything gets worked out, we get that P1 is equal to 29.5127. Keeps on going. Sorry, my pen stopped working. There we go. 29.5127 ... kilopascals. Go back to the question. Everything's got 3 sig digs, so your answer needs to have 3 sig digs as well. 29.5 kilopascals. Life's good. Got it. 3 sig digs. All right. I wish I could say any questions that you want to ask and just get instant conversation, but that's not our reality. So, as I mentioned before, email me. By all means, let's see if we can figure out anything that might be not clicking in your brains. One more question, and then you really should go and try some of these on your own. So here we go. We have a flexible container with, ding, 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 notice those units. As soon as you see liters, that's a volume. So here's our initial volume. This initial volume is being held at this. Notice the units, kilopascals. That means you've just been given an initial pressure. Here's a key language. If the temperature remains constant, that means that there is a temperature, but it doesn't change. Keep that in the back of your head. That's important. Goal of the question is, what will be the volume? So we're looking for a new volume if the pressure doubles, twice as much as it was. We still have our initials and finals. Here is your first volume. We're looking for the second volume. Here is your first pressure. We've been given a way to find the second pressure. Temperature, though, doesn't change. So something different happens there. Write down what you know still. Initial volume equals, and this one is 4.0 liters. Initial temperature equals, and just write the word constant, because nothing's going to change there. Okay? Initial pressure equals 200.25, remember your units, kilopascals. Now we get to V2. This is the whole point of the question, so I don't know. T2, same thing. Temperature remains constant. So write down the word. It is constant. And our final pressure, the initial, is going to double. So we're going to go 2 times 200.25 kilopascals, which works out to be the grand total of 400.50 kilopascals. Okay. Like I said, check out the whole point of the question. We're looking for V2, but you can do something else here. We can take that initial temperature and that final temperature and cross them right out. Because they don't change, they don't have to be factored into the equation. This makes it way easier. Consider, write down your formula. P1 V1 over T1 equals P2 V2 over T2. If temperature remains constant, you can take it out of the equation. It's completely gone. So in other words, we have a simplified equation. P1 V1 equals P2 V2. Makes it a little bit easier. Our goal here, of course, is to look for V2. So nothing changes in that way. You still need to make a point to rearrange it. P2's in the way, divide by P2, we do to one side, we do to the wonderful other side, and those cancel out. So we still manipulate the formula, it's just a little bit easier with the temperature gone there. P1 V1 over P2 is going to equal V2. Plug in what you know. With units, nothing changes. 200.25 kilopascals times our initial volume, 4.0 liters, divided by my final pressure, 400.50 kilopascals, equals, now watch what happens here. When you work that out, you get a total of 2 liters. That, folks, isn't enough sig digs. If you go back to the original question, it shows that we must have 2 significant digits. So 2 liters is wrong. Okay, you would have to take that and recognize that V2 is actually equal to 2.0 liters. Watch your significant digits. All right, like I said, feel free to watch again if you need to. This now takes us to the last part of your homework assignment that you are able to finish. So in other words, do the rest. Submit it to me, please, and I will mark it and get it back to you. Hope you guys are well, thinking and praying for you constantly.